Determining if 6-gauge wire is suitable for a 50-amp service to shop involves several considerations. The primary concern is whether the wire can handle the anticipated load over the 150-foot run. For a 150-foot run at 220 volts, 6-gauge wire is generally adequate for a welder drawing up to 50 amps or a compressor drawing up to 65 amps. However, it is important to consider the potential for voltage drop over this distance. Voltage drop occurs when the voltage at the end of the wire run is less than the voltage at the source due to the wire's resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. Use an online voltage drop calculator to determine the actual voltage drop for your specific situation. Factors affecting voltage drop include the wire gauge, the length of the run, the current drawn, and the wire's material, which in this case it is assumed that the wire is copper. If the calculated voltage drop is significant, you may need to use a larger gauge wire to minimize it. Remember to check the specific voltage requirements of your welder and compressor. These requirements are typically listed on the equipment's nameplate. Ensure that the voltage at the shop, after accounting for voltage drop, falls within the acceptable range specified by the manufacturer. In addition to wire gauge and voltage drop, proper installation practices are crucial for safety and reliability. The wire must be installed in conduit to protect it from physical damage and environmental factors. Select the appropriate type and size of conduit for the application. Factors to consider when choosing conduit include the number of wires being run, the environment in which it will be installed such as indoors or outdoors, and any applicable built-in codes or regulations. Use appropriate fittings to connect the conduit sections and to attach the conduit to electrical boxes or equipment. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to prevent electric shock and equipment damage. Install a ground rod near the shop and connect it to the grounding wire in the conduit. The ground rod should be made of copper or copper-clad steel and should be driven into the ground to a depth that ensures good electrical contact with the earth. The grounding wire in the conduit should be connected to the ground rod using a suitable connector. Connect the grounding wire to the metal frame of the shop if applicable. This will help to ensure that the entire structure is properly grounded. Install a 50-amp circuit breaker in the main box to protect the wire and equipment in the shop. The circuit breaker should be sized to match the ampacity of the wire. The ampacity of a wire is the maximum amount of current that it can safely carry. For 6-gauge copper wire, the ampacity is typically around 55 amps, but this may vary depending on the wire's insulation type and installation conditions. It is important to select a circuit breaker that is rated for the voltage and current requirements of the equipment being powered. The circuit breaker should also be of the correct type for the electrical panel in which it is being installed. It is necessary to check the National Electrical Code, also known as NEC, for specific requirements and guidance. The NEC is a widely adopted standard for electrical installations in the United States. Local jurisdictions may also have their own electrical codes or regulations. It is imperative to follow all applicable codes and regulations to ensure a safe and compliant installation. Here are additional tips for the installation. Firstly, use high-quality wire and materials for a safe and reliable installation. Secondly, label the wires clearly to prevent confusion and ensure proper servicing in the future. Thirdly, consult with a licensed electrician if you have any doubts about the suitability of the wire or the installation process. Fourthly, ensure all connections are secure and properly tightened to prevent overheating and electrical hazards. Fifthly, test the installation thoroughly after completion to verify that it is working correctly. Sixthly, keep a record of the installation, including wire sizes, circuit breaker ratings, and grounding details for future reference. Ensure that the 600-volt rating of the wire is suitable for the 220-volt application. The voltage rating of a wire indicates the maximum voltage that it can safely withstand. Using a wire with a voltage rating that is too low can result in insulation breakdown and electrical hazards. The 600-volt rating is more than sufficient for a 220-volt circuit, providing an extra margin of safety. If the wire is exposed to sunlight or other harsh environmental conditions, use a sunlight-resistant or UV-resistant type of wire. Sunlight can degrade the insulation of some types of wire, leading to premature failure. UV-resistant wire is designed to withstand the effects of sunlight and maintain its integrity over time. When running the wire through conduit, be sure to avoid sharp bends or kinks. Sharp bends can damage the wire and reduce its ampacity. Use appropriate bending tools to create smooth, gradual bends in the conduit. When pulling the wire through the conduit, use a wire pulling lubricant to reduce friction and prevent damage to the insulation. Do not exceed the maximum fill capacity of the conduit. Fill capacity is the maximum amount of wire that can be safely installed in a particular size of conduit. Overfilling a conduit can make it difficult to pull the wire and can also lead to overheating. Be mindful of directing factors when calculating the ampacity of the wire. Directing factors are adjustments to the ampacity of a wire that are required when multiple wires are installed in close proximity to each other, or when the wire is exposed to high temperatures. Directing factors reduce the ampacity of the wire to prevent it from overheating. Ensure that the wire is properly supported within the conduit. Use cable ties or other suitable supports to keep the wire from sagging or rubbing against the inside of the conduit. The support should be spaced at intervals that are close enough to prevent the wire from moving excessively. When connecting the wire to the circuit breaker or other equipment, use the correct size and type of connectors. The connectors should be designed for use with the specific type and size of wire being used. Torque the connectors to the manufacturer's specifications to ensure secure and reliable connection. Avoid over-tightening the connectors, as this can damage the wire or the equipment. Inspect the wire regularly for signs of damage or wear. Look for cracks, cuts, or abrasions in the insulation. If any damage is found, replace the wire immediately. Keep the area around the electrical panel and equipment clear of obstructions. This will allow for easy access for maintenance and repairs. Store flammable materials away from electrical equipment to prevent fires. Consider installing surge protection devices to protect your equipment from voltage spikes. Surge protection devices can help to prevent damage to sensitive electronic equipment caused by lightning strikes or other electrical surges. Ensure that all electrical work is performed by a qualified electrician. Electrical work can be dangerous if not performed correctly. A qualified electrician has the knowledge and experience to safely and properly install electrical wiring and equipment. Consider future electrical needs when planning your shop's electrical system. Install additional circuits or conduit to accommodate future expansion or equipment upgrades. This will save you time and money in the long run. If you are unsure about any aspect of the electrical installation, consult with a licensed electrician. A licensed electrician can provide expert advice and ensure that your electrical system is safe and compliant. Remember that electrical codes and regulations are constantly evolving. Stay up to date on the latest changes to ensure that your electrical installation remains compliant. Participate in continuing education courses or workshops to enhance your knowledge of electrical safety and best practices. By following these guidelines, you can ensure a safe and reliable electrical installation for your shop. Safety should always be the top priority when working with electricity.